Okay, I believe I'm now live. So, welcome back to LiveWork, where today we're gonna be doing some first order differential equations problem from the 1803 exam one. So yeah, so we are gonna be doing lots of integrals and also some graphing. So yeah, let's hope nothing should be that bad. So yeah, in total we have 5 points. Though total points is 100, but yeah, obviously we are not really gonna be carrying a lot on the scores. So yeah, let me just go and do this first here. Present. There we go. Oh nope, never mind. Let's do it like this. There we go. That's better. So okay, let's go with the first problem, shall we? Let's see here. Screenshot. Yep, there to there. Okay. In a perfect environment, the population of Norway rat that breeds on the MIT campus increases by a factor of E each year. Model this natural growth by a differential equation. What is the growth rate? Okay. Huh. We just started straight away with this Norway rat problem that breeds on the campus increases by a factor of E each year. So this thing is going to be natural growth. So yeah. Um So yeah, let's just straight away and just write the answer. So yeah, basically in here, I will say that yeah, the population would be R for rats. So yeah, let's do the change of R over the change of time would equal to, well, let's see here. This guy, this thing increases by a factor of E. So yeah, basically when you have this amount of rats, let's say for example, if you have R amount of rat, within time t, it would increase by E. So that would be that. So what's the growth rate? K. In this case, it would be E. Because like, yeah, it increases by a factor of, wait. Yeah. The, yep, the answer should be E. Because like, yeah. Oh, wait. Rat that breeds increases by a factor. Oh, wait. So it increases E times the amount of rat that you have. So yeah, basically the growth rate here should be E. Pretty simple. Okay. MIT is a limited environment with a maximal sustainable Norway rat population of 1,000 rats. Write down the logistic equation modeling this. You may use K for the natural growth here if you fail to find it in A. Okay. So yeah, we are gonna be doing some logistic equation of a growth. Uh, I believe it's like something. Where is the logistic growth? Um, let's see. Could I actually find it here? Okay, there it is. Oh yeah, yeah. So yeah, in here, the logistic here would be let's let's write this. E would equal to A minus by. We start by that. And so we know what the dy dt would be. Well, actually this thing should be r. R. This one would be r. This would equal to a of r minus br squared. So I hope that's the correct answer. So, okay. Let's go with problem 3 here. Oh, no, sorry, it's problem C. The MIT Pest Control Service intends to control these rats by killing them at a constant rate of A rats per year. If it wants to limit the rat population to 75% of the maximal sustainable population, what rate A should aim for in rats per year? Okay. Oh wait. Okay. So basically you want it to be like change of R over the change of time here. Would be oh wait. Okay. Oh wait, actually this thing here doesn't actually make any sense because like, yeah, that's only A and B. Ah. Oh yeah. Let's just go ahead and just solve this problem first. So when will this thing actually be sustainable? Because like, okay, first things that I see here is that this is a autonomous equation because there is no t on the right hand side. So yeah, so yeah, we can actually just try to find where where it would be stable just by replacing this the rdt by 0. So what you'll get is actually br squared must equal to ar. Therefore, wait, what? Okay. Wait, what? um. Oh wait, what? Okay, okay, okay. Sorry, my bad. So like, yeah, according to my logic, like, yeah, the e here actually doesn't make any sense because like, yeah, obviously the growth rate here couldn't be e because that would be so easy. But yeah, the problem would have 8 scores. So yeah. So yeah, we are gonna be doing this differently. So instead, we are gonna be modeling this because like, yeah, this one here actually is stating that it's a perfect condition, which means that we could actually say this as dr dt equals to k of r. That was my first intuition after all. And so you could just figure out what the r here is. So r would equal to um, this is e to the power of kr t, I believe, multiplied by a constant a for example. Let's make sure this thing is correct, just in case, because obviously that, yeah, that yeah, my brain would obviously shut down if this thing is wrong. E to the power negative k r. You take the that would be a constant. Yeah. Oh yeah. Yep. This thing is correct. Oh wait, no. Actually, let's try to recheck this just in case. So the k of r would be this guy. You take r is a e to the power of k r. Wait, no. No. There shouldn't be any r there. That's why. So it's a k e to the power. No, it's okay, and then you take the derivative. Yeah. So yeah, it's this. Okay, good. Okay, so now yeah, let's go ahead and just figure out, because like yeah, the population actually increases by a factor of 2.71 every year. So yeah, during time zero, we are gonna be comparing things. R would R would equal to A, but when time is one, R here would equal to e to the power of k, a e to the power of k. And so when you take the ratio, this thing should be e, because that's the factor. So when you do that, e to the power of k, we got k is 1. Good. So therefore this thing here must be k. But yeah, obviously the k here is actually different. Wait, no, actually not really. You may use k for the natural growth here. Okay, too bad. Wait, what? You may use k for the natural growth here if you fail to find it in A. I don't I don't get this line. Why do you actually need to put that line? But whatsoever. So yeah, let's actually just figure this out instead. So yeah. So what you'll get is actually this thing here to be 1, right? Yeah. The k here would be 1. MIT is a limited environment with a maximum sustainable rate. Like yeah, for my own intuition, I would personally try to find out where would this thing actually stabilizes, which in this case I figured this out already, that R is A over B. Yep, R is A over B. which is the stable equation, which means this guy is 1,000. Good. So therefore, when you plug the entire numbers in, we hope that the result would be 1,000. Ah. Oh, but yeah, obviously you know that 1 plus BR. Wait, no. The thing actually changes. Wait, what? Wait, what? Why does it all not make sense? Uh, hmm. Something is not adding up. If you put that guy there, that would be minus 999, which obviously doesn't make sense. Oh my, oh my. I don't think K here is that. Uh, we call this doubt. I'm doubt. I'm just doubting this entire thing. Doubting. Um. Hmm. Huh. Why does my logic doesn't work? I know that this thing is a autonomous system. Like yeah, the other point would be when R is 0. As yeah, no rats there, no rats would be alive. Okay. Uh, can I use logic to solve this? No. What is A? A is minus 1 over 999. Which obviously doesn't make sense. According to the answer book, it is 1 minus k over 1000. Which I still can't figure out why. Wait, what? Why? So the k. So yeah, according to my book, the k would be a minus by. So that will be the growth rate. But it, but the growth rate here depends on time as well. So yeah. Oh, why are things getting complicated? Um, at this point, I'm just looking at my phone, just figuring out why. Uh, K is A minus by. Oh, okay. Like, yeah, obviously you could actually just rewrite things. So yeah, in fact that, yeah, this guy here is actually literally K. I have figured that out the entire time. But then, yeah, obvious. Wait, what? Wait, what? What are you talking about? um, why do things doesn't make sense? Why is it 1 over R? That is a pretty good question. Why is it 1 over R? Because... Oh, okay. Instead, instead of starting like this, let's let's just do this differently. Let's restart the entire thing and think naturally. So, okay. We are still going to be having this dr over dt, and then you obviously have this k here representing the growth rate. But then yeah, it should reach towards a limit, which is which should be this number here. 1000 of x here. Multiply this by x. Because like yeah, this is basically the rate that you have initially, but yeah, obviously you have this guy here, which also limits how many how many will you have at the maximum. So yeah, basically at 1000 it should be 0. That is the theory. But then you know that k is 1, so you can ignore this. So we got this function here. Okay. So I just did that. I'm so sorry I just cheated, but yeah. But yeah, logically it's that. Because like yeah, obviously I didn't study for this entire thing. It's that I just do it myself. Okay. So let's just do part C. Yeah, the pest controls want to do that. If it wants to limit the rat population to 75% of the maximal sustainable population, what rate A it should aim for? Okay, so in fact this thing actually turns into a new problem, which is x minus x squared over 1000 Subtract this by A. Okay? And we want to make sure that this guy here is stable. I'm hoping this would be stable when when the R, wait, why did I change that to X? This should be R. So it's R squared. Okay, there. So yeah, I want this R here to be 3/4 of the first R. So yeah, in fact, in here I would state that this would be RC, representing the problem. This one would be RB. RB. There you go. So what you want is RB to be 3/4 of RC. That's basically the problem that we want to solve. And so when you just take this guy to be 0, this would equal to RC squared over 1000. Subtract that by, oh wait, this guy would actually mean 750. And this RC plus A. There we go. And so when you plug in the numbers, that would be 750. Subtract this by 75. 75 times 75, that would be 70 times 8500, 5625. 5625. With another 2 zeros. Divide them. Wait, really? 70 times 80? What's that? 70 times 80, that would be... How many is that? 5600, yeah. And then you add the 25 and then you add the other 2 zeros. So it's 562,000 and something. There you go. You can cross out the backside there. This would equal to the A that we want. So the A here would be that minus 562.5. That'll be 0.5. So that's 10 turns to 9. That's 7. And then that's 4, 18. Wait, what? 4. Wait, what? Wait, what? what? Yeah, when 4, that'll be 8, 6, 1. Just to recheck, because obviously I don't trust myself doing this calculation. It is correct. So yeah, this should be the rate of you actually killing those rats in order to achieve this 750 rats. Okay. I guess that's fine. Like, yeah, the thing that I only struggled was to actually model this thing. So yeah, I actually forgot about logistic growth. So yeah, with that, I would say in here, I would say I don't get any points, but yeah, you know, this entirety should be 20 points. Okay, but yeah, instead, yeah, obviously we learned from these mistakes. So yeah, let's go to the second problem, shall we? I actually want to see the other stuff. Could I do that? Could I just minimize this? Yes, I can. Good. Very good. Let's see here. There we go. Okay. Let's go to the second problem here. Present. Oh, there you go. Problem 2. Place file place Okay. For the autonomous equation x dot equals to x minus 1 plus x plus 2, please catch the phase line, identifying the critical points and where they are stable, unstable, or neither. And part B, at least one solution of each basic type so that every solution is a time translated. Okay, below is a diagram of a direction field of the differential equation. On it, please plot the no wait, what? Okay, we don't have the diagram of the direction field of the differential equation of y prime equals to that. So unfortunately I need to try to find it first. Let me just go and open that link in a new tab. Okay, there we go. Let's just take this guy instead. The answer one, but yeah. I feel bad actually opening this up. Okay, there we go. Could I actually make a direction field? Let's see here. You know what? Nah. Because like yeah, obviously making a direction field would be longer, but yeah. But yeah, you know how to make a direction field. So yeah. Instead, I'll just actually go in here, place that guy in. There you go. Oh, but yeah, you can't see it clearly, so yeah. I guess I need to actually to help with that. So yeah. For the phase line, identifying the critical points and where they are stable and unstable, or neither. Okay, so first things first that you need to know is that when you're trying to find the critical points, you just need to find where it's 0, 1, 2 or something. So yeah, obviously in here, I can clearly see that this entire thing here would be 0, as as that is one of the critical points, and then you have 1, and then in here would be -2. Okay. Okay. So we have figured this null line here, the phase line, and then you want to figure out where this would be stable or not. So yeah, let's go and just check it first. So yeah, let's say at point a little bit above 1. If it is a little bit above 1, this would be positive, this would be positive, and this would be positive. That means that it would go up. Okay, good. What happens when it is slightly below 1? Well, one of them would be a negative. That means that this guy would go down. But then, okay, so this guy goes down. But then what happens when it goes slightly below 0 or slightly above negative 2? So yeah, when it's slightly below 0, it would actually go something like that. And then when it is below negative 2, it would go out. So with this, you can actually see that this guy here is, let's just type that, this guy here is unstable. This one here is unstable. And this one here is stable. So that's basically the sketch that I would actually draw. And then at least one solution of each basic type. So yeah, let's go and just find a function which starts from this, which starts from above 1. It would later go higher and higher. But what happens when it is slightly below 1? You could say it would tend towards 0. Let's just keep on continuing this starting. When it is near negative 2, it would tend upwards like that. But then when it's below there, it would tend towards negative infinity. And that's how you draw these things. Like, yeah, that's my best sketch. So yeah, you just basically follow the, you just follow the arrows to determine where do you go. Do you go up or do you go down? And you will never cross the, you cannot touch the isocline of 0 or the nullcline. Okay, below is the diagram of the differential equation of y prime is 1 over 4 x minus y squared. On it, please plot and label. So yeah, in here we need to figure out where would the nullcline be, where x would be 0. So yeah, when you just solve this, it's our problem here. 0, it would be y squared minus x, which should be something like this. There you go. This thing here is the nullcline. And then at least 2 different solutions. So yeah, in here it has been sketched some. So like yeah, for example, in here this guy goes down and this guy goes nearer there. But then yeah, some of them goes here and then it just goes down. It is 2 different solutions. But yeah, obviously you can also draw some other solution that goes something like that. Some of them go something like that there. You could see it there from the graphs. Some of them even go something like this here. So yeah, this would be D1, D2, D3, D4, and D5. Okay, E, the separatrix, if there is one. Okay, so yeah, basically the separatrix is basically the one where it is unstable. So yeah, as it goes towards infinity, it would start to break out. And this would actually be the, so yeah, in here, this bottom side here, this is the, that is the separatrix, which I'm going to be labeling it with the color red. Red. So this part here is the separatrix, because it is literally unstable there. Like yeah, no one wants you to go there, but there is a chance that you could actually be there. But it is very unstable. So that's why it just starts flinging off. But then you also have the, Oh wait, no, you don't have the funnel. Oh well. So yeah, that's basically the separate tricks. True or false? If is a solution with a minimum, then for all large enough x. Wait, what? Wait, what? What is the question? If yx is a solution with a minimum. Okay. Okay, yeah. Then for all large x, y y of x. Yeah, it's true because like yeah, from we see here, the minimum is actually where it actually bulges down and then it just goes back up. So basically, the solution here is gonna be always true because like yeah, obviously y squared x would would be one of the parabolas of the no sorry, it is one half of the sideways parabola. And yeah, you can see from here that yeah, for large enough x, it is just basically this guy here. The value is less than square root of x, which is true. But then yeah, obviously this one here. Oh wait, actually, this one here is a minimum though. But as it tends towards infinity, it's not. No, like yeah, for example, like this solution here, that solution there is actually bigger than square root of x, which which obviously you could tell. But yeah, somehow the thing actually states that yeah, it shouldn't have any minimum. But yeah, um, let's see. After the solution is parabola is positive, so but the slope of the north plane is positive. Well, is zero, so it does not cross. It stays below the upper branch of the north line, which has equation y equals square root of x. Huh? Huh? Really? Wait, really? Like I cannot really tell. Mm-hmm. Actually, like yeah, according to my theory, because like yeah, this thing is actually a bit of a maximum. Oh wait, y squared of x is actually the null line, right? Oh yeah, that's true. Because we are not talking about the maximum. Instead, we are talking about the null line. So in fact, that would be true. Because like every single solution will actually pass towards the parabola of the y equals to square root of x. But then yeah, after that, it would go up. No, it would try to go up. But yes, it couldn't actually pass the square root of x. So this would be true. Oh, wait, actually, no. Wait, what? Wait, what? My logic doesn't seem to work at this point. Uh, if you have a parabola, if yx is a solution with a minimum, then for all large enough x, for all large enough x. So when you go into a very large number, yx would be less than square root of x, which I would say it's true. What? No, 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 wait. That will be the null claim, right? So you pass through the null claim, but then it... Oh, yeah. It would be true. Because, like, basically that logic. So basically, like, let's say for example that, no. So if you have a parabola like this, and then you have, like, these guys here, this guy would be the minimum, right? But then it would try to go back up, right? But then instead, it cannot actually go and pass this thing again. Instead, instead it would try to go near it, but it cannot pass through it, because when you actually pass through this guy, the slope must be positive. But in this case, the slope is actually ne- negative or zero, basically. So yeah, it would be true that it cannot pass the square root of x when the x would be large enough. Good. I hope that the explanation is better than my previous ones. Okay. Anyways, problem number 3. Wait, what? Yep, there we go. Third problem here. Measure 4. Boom. There you go. Place. There you go. Oh, there you go. Okay. Let's hope that my mic is still on. Just in case, yep. There we go. And it is now at 72 degrees. I know. So okay. Use Euler's method with step size h equals to half to estimate the value at 3/2 of the solution. Okay. So in this case, the way basically the way for me to actually to do Euler's method is just by drawing a graph. You have n here. You have x right over there. Oh, let's draw this perfectly. There we go. It starts from 0. X here is 0. The y of y0 would be 1, as been told by the question. And then I'll write this guy as y prime m. This would be the slope. So yeah, the slope here would be 0 plus 1. That would be 1. And then after that, this is m multiplied this by the change of x, which in this case it's called h. This would be half. Okay, good. And so secondly, let's do this for the second one. Step size of half. No, sorry. We jump towards this x equals to half. So when this thing is half, you just basically take 1 plus the half of from the mh, which is basically the change of y. So this would be 3 over 2. And then the m here would be half plus 3/2. That would be 2. Therefore, the solution here would be 1. Okay. Second step. Let's do the same thing here for 1. This one would be 5 over 2. That's 3/2 plus 1. And then, so the m would be 1 plus 5/2. That would be 7 over 2, or 3/2. Therefore, the mh there would be 1 3/4. And so lastly, when you take the third part, this would be 3 over 2, the one that we want to figure out when x equals to 3 over 2. The result would be 5 over 2 plus 7 over 4, that would be 17 over 4, which equals to 4 quarters. And that's the answer. Okay, good. Find the solution of tx dot plus x cosine dot such that x pi is 1. So this is an ODE with a IVP, with an initial value problem. So yeah, figuring this out should be pretty easy. So yeah, first things first, let's make this linear equation into a let's actually generalize this entire thing. Cosine t over t. Okay, but then I just realized, I don't like this cosine t. Why? Because like, yeah, cosine t, it is hard for you to actually calculate. When you just try to find the integral of the thing, I don't like it. So we just go into the complex world, where we are going to be dealing with complex numbers. So in fact, what I can do is that I can actually figure what this thing is. So yeah, let's try to figure this out. This would be e to the power of it. So yeah, that's basically the cosine t, but yeah, this t here, this guy here is stuck. And let me just erase that. Like, yeah, this guy here is actually stuck here. The over t here is actually stuck. But yeah, obviously we are going to be trying to find the real value of this guy. Because like, yeah, if you don't know about complex powers, you should learn it. Because like, yeah, when you are solving these problems, it is easier for you to actually to turn it into a complex power. So yeah, in fact, what this 1 over t here actually means. So when you take that, like, yeah, my brain cannot actually process such things. Oh no, this is gonna be chaotic. I know. Oh, okay. Wait, what? No, it doesn't work like that. What's 1 over t? Wait, actually, mm, it's the e to the power of natural log of 1 over t, which should be the real value of. So this guy here is e to the power of natural log of that. So this would be e to the power of the negative natural log of t. Yes. Plus it. Oh yeah, that's better. I, s- I would say that's better. I would say so. Because I said so. Wait, what? No. No, wait. This thing makes things a bit much more complicated. Man, I cannot. I cannot. Oh no. This is the worst case scenario. Oh. It's t to the power of negative 1. Unfortunately, I cannot do that. Why? Why can't I do that? The question is, why can't I do that? Why? I don't actually really know. Uh, huh. Because what you actually need to do is to find the integral of that thing, which is terrible. I cannot, like, yeah, I cannot actually convert that into a function with t on it, right? Right? Huh. Wait, no. No, wait, what? Like, yes, I know that it's hard for you to actually calculate this thing. But what if you try to calculate it? What if you want to try to calculate? No. I would rather say no. Oh, wait, actually, before that, I might actually engineer a different way to do this instead. Let's just try this out. I don't know. I don't know if this would work or not. But yeah, let's try this out first. Because because what you want to do is actually to multiply this by a value in order to make things much more easier for you to do this. So yeah, in this case it would be, oh my gosh, this is already a very simple problem. Oh my gosh, what am I doing? I didn't actually see this coming. Because from what I actually just myself realized that t t of x, when you just try to derive that, that would be this guy. I know some of you guys are actually are already screaming at me. It's like, you just need to do that. But yeah, somehow I am too stupid to realize that. Ah, x is sine t over t plus c over t. When you plug in that the number is pi, sine of pi would be 0. That means that c over pi would be 1. That means c would be pi. Therefore, what you get is the solution would be the sine of t over t plus pi over t. That's why I was struggling a lot. Huh. I don't know why. Okay. Um. Okay, so that's problem 3 solved. Good. Okay. Let's go to the next problem. Hmm. I'm trying my best actually to explain this, but at this point I cannot actually explain lots of things, which I am sorry about. Okay, take a screenshot of that. Yep. Problem 4. Wait a minute, let me just do something first. Okay, let me just get myself configured again. Okay. Hmm. Let me just go and place this first. Huh. There we go. Okay. Problem 4. Find real AB such that 3 plus 2i equals to a plus bi. For you guys who actually already do complex numbers, pretty easy for you. The multiply the top side and the bottom side by 3 minus 2i. Obviously that would mean that the answer would be 3 over 13. That would be A. B would be minus 2 over 13. B equals to negative 2 over 13. Yep, that's that. I'm so sorry if my writing is so bad. Okay. Second problem. Find real r and theta such that I minus I equals to r e to the power of I theta. To do this, the r here is actually the length, which is basically 1 squared plus negative 1 squared. That would be square root of 2 to the power of e to the power of I. And then when you just look at a complex plane, where is 1 minus I in the theta direction, that would be negative pi over 4. So it's minus I pi over 4. And so yeah, obviously this is where the e to the I pi actually comes from. E to the I pi is negative 1. Or e to the I pi plus 1 is 0. So yeah, this is where it all actually comes from, which is from complex stuff. Okay, C. Find real a point B such that 1 minus I to the power of 8 equals to a plus bi. Ah, this is where I hate doing this, but oh well. Let's just do this. So first, let's actually go and compute what 1 minus I squared is. So it's 1 minus 1, that's 0, minus 2i. There you go. That's the solution. Oh wait. And then after that, you try to compute this again, which actually ends up with negative 4 squared. Because obviously I is actually square root of I, so yeah, when you just basically just take the square of that, it will be 4 times negative 1, which would be this. So this would actually result to 16. So A is 16, B is 0. And here I didn't write anything, R is square root of 2, theta is minus pi over 4. Okay. Part D. Find real a point B such that B is bigger than 0 and a plus bi is a cube root of negative 1. Okay, you want to try to find the cube root of negative 1. You first actually convert this into polar coordinates, which would be e to the I theta, e to the I pi actually, e to the I pi, there you go. And then you take the cube root. So when you take the cube root, it basically means that you just need to divide this guy by 3. And yeah, there is obviously 2 different solutions. One of them is pi over 3. The second one is obviously 2 pi over 3. Well, actually there's a third one, but who really cares about that one? So funny, right? I hope I never do that joke again. So when you take the cube root of this guy here, so it's e to the I pi over 3. And what's that? Pi over 3, that means that the cosine would be, what's the cosine of pi over 3? Half. So it's half plus square root 3 over 2. I. This would be A, this would be B. Just to check, you can just do the calculation, which means that the answer would be half plus 3 squared 3. No, minus 3 squared 3 over 4. Wait, what? No, 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 no. Something's not adding up. Oh yeah, yeah. Oh wait, what? So you first take the cube root. That's 1/8. You take the square of that one, which would be 3/8. 3/8. No, so then you subtract by 3/8. That would be, wait, what? No, nothing makes sense at this point. I know. So when you have pi over 3 and then you just add, wait, what? Wait, what? Things doesn't make sense. Huh? 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 Such that b is bigger than 0. Oh wait, there's actually two different solutions. I think. I think there's two different solutions. Wait, what? So I know that a to the I pi over 3 is that. There is actually another solution. Yeah, which is when it's for. Wait. Wait, what? The sum of the entire thing must result to this guy, right? You know what? This is actually the most simplest solution. At this point, I just say, nah, I don't want to dive into that thing. But yes, there's actually another solution, which I believe it's negative pi over 3. No, it's not negative pi over 3. It's negative 2 pi over 3. 1, 2, 3. No. No, 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 no. No, it's pi over 3, pi, and then it's negative pi over 3. Yeah. So those are the three solutions, but obviously this one is the most accurate of them all. Oh my, oh my. Oh wait, yeah, it's correct. I did the check again in my mind, so yeah, good. Ah. Find real a point. Oh, okay. First things first, e to the I pi is obviously negative 1. So it's actually negative 2. What? Negative 2? Wait, really? Like, yeah, everything is actually multiplied by 2. And then I pi cosine theta is negative 1. Sine theta, yeah. The answer is actually negative 2. Okay. Write ft equals to 2 cosine 40 minus 2 sine 40 in the form a cosine omega t minus phi. Okay. For this one here, you actually, so yeah, basically a here is actually the length of 2 and negative 2, which would be square root of 8 cosine 40, which we actually copy. Subtract this by the angle that you make. So yeah, cosine here. So yeah, you got 2 minus 2 to the bottom. That will be minus pi over 4. This will be plus pi over 4. That means, and that's the answer. Good. That's a quick one. So let's just go to the final problem. Problem 5. Okay. There. File plus there you go. Find a particular solution to the equation x dot plus 3x equals to e to the power of 2t. Okay. To do this, we are actually going to be doing the we are going to be multiplying the entire thing by e to the power of 3 dot, no, 3t plus 3e to the power of 3t of x would equal to e to the power of 5t, which would literally mean that e to the power of 3t of x would equal to this guy integrated, which would be e to the power of 5t divided by 5. Add this by a constant. So x here would be 1 over 5 plus c e to the power of negative 5, negative 3t. No, this should be e 2t. Because this is 3, that means it's minus 3t. There we go. Yep. Yep, my writing is so bad. Part B. Find the solution to the same equation such that x naught equals to 1. Okay. So when you plug in 0 into the mix, x would equal to e to the power 2, no, 1 1 would equal to e to the power of 2t over 5. 0, that would mean it's a plus c, a constant. Yep. Yep. Oh wait, what? No. Wait, what? Yeah, oh wait, yeah. E to the power of 2t, that would be 1. Because like, yeah, you just substitute the 2t, that would be 0. E to the power of 0 is 1, so yeah, it's so the c here would be 4 over 5. Therefore, x would equal to e to the power of 2t over 5 plus 4, well actually yeah, plus 4 over 5 e to the power of 3t. And that's the solution. Good. Part C. Write down a linear equation with exponential right hand side of which x dot plus 3x equals to cosine 2t is the real part. Okay. So we just need to find this first. Okay. X dot plus 3x would equal to e to the power of 2it, which you take the real part, obviously. Like yeah, you should write the real part at the very beginning, but yeah, at this point I'm too lazy. And then find the particular solution to that problem. Okay. So same stuff. E to the power of 3t of x would equal to 1 over 2i plus 3 of e to the power of 2it and then plus 3 plus constant. There. X would equal to e to the power of 2it, and then this guy I want to convert that into i's as well. Square 13 e to the power of it as well, e to the power of wait, what's the angle? And that will be tangent of 3 over 2, which is something that you don't know. Ah! You know what? Yeah. Instead, I will just actually write this guy as uh, I will need to write it as as the other way. Oh wait, no, actually it's fine. Yeah, it's fine, it's fine. So yeah, you multiply this by the square root of 13, which is 4 plus 9 of e to the power of I of in here. Oh wait, actually this should be negative. This one, I would state this guy as phi plus c of e to the power of negative 3t, which would mean that this would equal to um, square root 13. So we got multiple i's there. We are just going to be computing the real part, so yeah. Cosine of 2t minus phi plus ce of minus 3t. And what's phi? When you just draw the triangle, this is 3, this would be 2, this would be square root of 13. And then after that you can actually just open up the entire thing here. So yeah, obviously you know that cosine of 2t is actually oh wait, no, this thing would actually be a square root 13 of cosine 2t minus phi is actually cosine 2t multiplied by cosine of phi plus sine of 2t multiplied by sine of phi. So yeah, basically cosine 2, so yeah. Let's just compute what is the cosine of phi here. Cosine of phi, this thing here would be phi. That's, wait, no, 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 no. This is 2, this is 3. Ah, that was safe. So yeah, when you calculate the phi here, that would be 2 to the square root of 13. So that means that this would be 2 cosine 2t. Add this by sine of phi, which would be, no, this is 3. Phi, which is 2 square root of 13. Yep, 2 square root 13 times square root of 13, that would be 2, so it would be 2 sine 2t. Add this by constant e to the power of negative 3t. Okay, okay, that's, oh wait, actually this is the final problem, right? Okay, yeah, so that's the final problem. Yay, we solved this entire thing. So yeah, I know I didn't actually explain lots of things that I actually talk about. I'm so sorry about that. Uh, because like yeah, unfortunately I cannot actually say lots of things that I actually speak. So yeah, I'm so sorry about that. But yeah, anyways, thank you very much for you guys who have actually tried to stick around, because I know this entire thing is actually very abstract. But yeah, I hope it helps for you guys who actually are gonna be doing differential equations. So yeah, thank you very much, and we will see you guys later. Goodbye.